step.
Hi, my name is Marlo Hood. Welcome to a new edition of the AFP Foundation's training course for journalists on climate change and sustainable development. For most of human history, nature has seemed an unmovable force. First, we lived in nature, reaping its bounty and fearing its outbursts. Then we sought to master and exploit it, bending it to our will. But until quite recently, it was difficult to imagine that one day we could fundamentally alter nature, and that our actions might incur a terrible cost. Well, that day has come. The driver, of course, is man-made global warming, and the price we will pay, correction, the price we are already paying, comes in the coin of climate change impacts. That's our focus for today. The impacts of climate change, I think, can be usefully broken down into three categories. The first is physical or natural impacts, such as temperature or sea level rise. The second groups the ways in which global warming will affect humans, individually and in society. Finally, there's a third category which, for the moment, we will simply call tipping points. We'll come back to it at the end. There are several important things to bear in mind before we catalog the consequences of pumping vast quantities of greenhouse gases into our atmosphere. One is that the severity of future impacts will depend almost entirely on how quickly we stop doing that. Right now, we're on a pathway that would result in a global temperature hike of 4 degrees Celsius, a scenario almost too grim to contemplate. The best guess of most scientists is that if humanity can cap the rise at 2 degrees Celsius above the pre-industrial benchmark, humanity should be able to avoid climate catastrophe. Others, however, say that may not be good enough, pointing to the damage occurring with less than 1 degree of warming so far. The second important point is that climate change impacts interact and are deeply intertwined, much like the different strands of the Earth system itself, its biosphere, atmosphere, hydrosphere, geosphere, etc. This means that relatively small changes can lead to dramatic outcomes. A slight increase in the force of a tropical storm, combined with a small hike in sea level, for example, can be a recipe for superstorms with vastly enhanced destructive potential. Sometimes, in nature, 1 + 1 = 3. Finally, we shouldn't forget that many impacts stemming from climate change are amplified by other types of human activity. Ocean acidification caused by the increased absorption of CO2 is the main reason half the world's coral reefs are dead or dying. But runoff from agriculture, pollution, dynamite fishing, and even chemicals and suntan lotions have all taken their toll. At the top of the list of physical impacts of global warming, as the name itself suggests, is rising temperatures, both above Earth's surface and in its oceans. The increase is unevenly distributed, higher at the poles and over land, for example, but on average, the planet's surface temperature has gone up by about 0.9 degrees centigrade in the last century. In addition, there's another 0.6 degrees of what scientists call committed warming already in the pipeline. That means that even if we could miraculously freeze CO2 levels in the atmosphere, a goal that's probably 4 decades away at best, we have already locked in a total increase of 1.5 degrees centigrade. That's 3/4 of the 2 degrees allowance that scientists have given us. The consequences of this warming are both measurable and worrying. In the Arctic region, where temperatures are going up at twice the global average, the polar ice cap is expected to disappear within a matter of decades. This will not add to sea levels, but it will remove a continent-sized mass of reflective snow and ice that helps keep the planet cool by bouncing much of the sun's radiation back into space. To make matters worse, the newly exposed deep blue sea is as good at absorbing the sun's energy as snow is at reflecting it. On land, rising temperatures are predicted to aggravate drought, And many scientists say we are already seeing that happen in the Sahel Desert, in West Africa, parts of the Middle East, and the western United States. In mid-2015, California put into place mandatory water restrictions for the first time in its history, after 5 years with almost no rain. Heat waves, like the one responsible for more than 15,000 excess deaths in France alone in 2003, are also set to become more frequent. Climate is best measured in decades or centuries, but one recent statistic is hard to ignore. 14 of the 15 hottest years on record, stretching back to the mid-19th century, have occurred since 2000. 2014 was the hottest of them all, which is one of the reasons the beginning of the 21st century has seen wildfires in Russia, Australia, California, of a rare and uncontrollable intensity. A small bump in temperature translates into a big increase in fire hazard. Climate models predict that more heat in the atmosphere means more powerful tropical storms, whether it be the hurricanes that batter the Caribbean and eastern seaboard of the United States, or the cyclones and typhoons that sweep across the Indian and western Pacific Oceans. But if these storms have become more deadly and destructive in recent decades, it is also because the surges they create today are engorged with extra centimeters of seawater, the 1 + 1 = 3 effect we just alluded to. Sea level rise is caused by several things, notably the expansion of water as it warms, and the melting of glaciers and blocks of frozen water kilometers thick called ice sheets. The two most vulnerable, atop Greenland and part of Antarctica, could together lift oceans by 15 meters. It might take centuries or millennia, but for the West Antarctic ice sheet at least, scientists say it is no longer a matter of if, but when. The oceans, working overtime in recent decades to absorb the extra CO2 humans have released into the air, have also become more acidic, a chemical change with potentially severe ramifications for life all the way up the food chain to us. The last major category of natural impacts we'll mention here, biodiversity loss, serves as a bridge to the human side of our story. Biodiversity loss is a bloodless term for something very dramatic, the quickening pace at which life forms are vanishing from the face of the earth. There are probably some 3 million species on the planet, most of them microbial and most undiscovered. But what scientists do know is that the rate at which species are disappearing has increased by at least 100-fold, perhaps 1,000-fold. That is a technical threshold for a mass extinction event, of which there have been only 5 in the previous 500 million years. There's a good chance, it seems, that human activity has triggered the 6th. Biodiversity loss is a consequence not just of global warming, but of many other factors too. At the top of the animal food chain, the main threat to endangered species on land and in the sea has been the human appetite, whether for meat, ivory, potions to boost sexual potency, or shark fin soup. We have emptied the oceans of half their living mass, mostly through industrial fishing and the destruction of coral reefs, which cover less than 1% of the ocean floor but harbor more than 1/3 of its life. The destruction of virgin tropical forests wipes out entire ecosystems with unparalleled densities of animal and plant life, ecosystems that cannot be easily restored or replaced. It does not take much imagination to see how all these impacts, driven and accelerated by climate change, have direct and potentially dire consequences for our species. Massive sea level rise alone would wipe out most of the world's great coastal cities and redraw the contours of our continents. But even a relatively modest increase of a meter, a likely scenario by the end of the century, would submerge entire island states along with sprawling river deltas in Asia, Africa, and the Americas that today support hundreds of millions of people and the agriculture that feeds them. Where will they go? And how will they be fed? Drought in Western and Southern Africa and the Levant is already having a cascading effect on human well-being that, in the short run, is likely to get worse. Staple crops such as wheat, sorghum, millet, and maize are unable to adapt quickly enough to new climate conditions, and yields are predicted to decline over the next half-century. Water shortages caused by the rapid draining of aquifers and the lack of rain are an incubator for hunger, disease, and even conflict. As always, it's the world's poor, living close to subsistence levels even under favorable conditions, who will be hit first and hardest by these intertwined impacts. Rich nations in North America and Western Europe, even if they are better equipped to adapt, will not escape the consequences of a climate-altered world either. Humanity is in a race against the clock. Two races, in fact. One is to decarbonize our economies and slash the greenhouse gas emissions largely responsible for these impacts. The other is to help communities, especially those on the edge, to adapt to climate-driven changes already upon us and build up resilience against those on the horizon. To win the race, we can only hope that the impacts that climate scientists fear most will not come to pass. We have described elsewhere the positive feedback mechanisms unlocked by global warming that feed on themselves, fueling further change. The release of methane from subarctic permafrost or ocean reservoirs, the melting of the ice sheets, the loss of the polar ice cap. Beyond a hard-to-define tipping point, any or all of these could trigger autopilot cataclysms that would upend the chemical balancing act we now call the Earth system. I've painted a grim picture, but it is not a hopeless one. There are solutions. Some of them seem far more realistic today than even a couple of years ago. But that is another chapter in our story. To find out more, we spoke to an expert on the impacts of climate change. Here's what he had to say.
The mounting changes that we've seen in extreme weather over the past 10, 20, 30 years, not only have they been able to document those changes, but they've been able to establish the fingerprint of global warming behind them. That in fact the weather has been changing for decades now, and that it's due to global warming. And that's been a real revolution in the science in probably the last 5 to 10 years.
Mm-hmm. So now we can say with a certainty that was not possible 10 or 15 years ago.
That's right. 10 or 15 years ago, they had hints that it could be happening, and they certainly had definitely firm projections that it would happen in the future. But now what we've done is we've collected the data to really be firm that it's already happening. And part of it is that when it comes to extreme weather and climate, scientists really like to see a long stretch of time go by before they feel confident about a trend. Because there's a fair amount of natural variation, right? So just the changes that you might see in 1 year or 5 years or even 10 years, they don't give them confidence that in fact this is something beyond the normal. But now we've got a data set of like maybe 30, 40, 50, 60, 80 years, and they've seen really clear changes in the last 30 years that go well beyond what we'd expect to see just by natural ups and downs.
Okay. We enumerate elsewhere in this program what some of those impacts are, and I'm wondering if you could help us make it real by focusing on 2 examples, somewhere in the world, some region, some country, where we can look and say impacts are happening here, that's what they are.
Yeah. Well, maybe if I could just start with the region where I'm from, just in particular, just because I think it's a very complicated one, but it actually, I think, helps illustrate the different ways in which climate change changes extreme weather, and that's the drought in California in the United States. And so one of the interesting things about drought is that it's driven by many different things. It's driven by changes in rainfall and snowfall, right? But it's also driven by extreme high temperatures. And in California, we've had both been happening. So there's been just a real absence of rain in California for like 4 years now. It's historic. But we've also seen really extremely high temperatures. And what the high temperatures do is they dry out the soils. Any snow that does fall falls as rain, and any snow that does fall melts. And in California, we get a lot of our water from the snow. The snow basically sits up in the mountains, and all summer long we count on the snow melt. It provides about 30% of the water in California.
Sierra Nevada snowpack.
The Sierra Nevada snowpack, exactly. So that's a good example of how we're very clear that global warming is driving the extreme temperatures. That's just firmly documented. And so we see how global warming is making the drought much, much worse. It's fueling the drought. Global warming may also be responsible for the shortfall in rainfall. Not so sure about that. Seems likely that that's what's going on, but we're not as confident about that. So that's a good example of how the science can be really confident about some things and less confident about others. And it shows how the picture is very complicated when it comes to, but the science is actually working all these things out to the point where we can actually parse out the different pieces and have different levels of confidence. And in the case of the California drought, we're very confident that the extreme temperatures are being driven by global warming, which is making the drought much, much worse.
Can you give us a second example, maybe from somewhere else in the world where those impacts might be felt differently?
Yeah, so I think another really good example are with the typhoons, and the typhoon that's, for instance, hitting the Philippines right now. And again, there's multiple pieces. So one of the things that we're really sure about is that the damage from typhoons is much, much worse now because sea levels are much, much higher. It doesn't take very much sea level rise to make dramatically more coastal flooding happening. So we're very confident about that. We're also very confident that the typhoons have a lot more rain in them now, right? Because a warmer atmosphere can hold more water. It's kind of like having a larger bucket. And when you empty out that larger bucket, it dumps out more water. And so typhoons now are dumping out a lot more water.
When you add poverty into the mix, and we're talking about impacts, can you contrast how that might play out in a place like California, which is a rich state and a rich country, and a place in the Philippines, which is not certainly among the poorest nations, but doesn't have the means that that the United States has, or even somewhere in the Sahel, for example, in Africa, where poverty really is an issue?
So I think that's a beautiful question because it illustrates that the risk from climate change depends not just on the changes in the climate, but it also matters about how much exposure you have, how vulnerable we are. And some people are less vulnerable and some people are more vulnerable. And so you could have the same typhoon hitting New York as a hurricane, typhoons and hurricanes are the same thing, having much less impact than the same typhoon hitting the Philippines because they don't have the infrastructure, they don't have the protection. And even interestingly, you can witness that change even in New York over time. There was a famous hurricane called the Night Train hurricane that hit New York back in the 1930s with basically zero notice. Like literally, people woke up with the hurricane on them. We had, due to modern forecasting methods, like a week's notice about Superstorm Sandy. And so that's an indication of how just having the resources and the satellites and the weather forecasting can really make people prepare and be ready for those extreme weather events. And so that's a good example of the kind of infrastructure that developing countries need. Something as simple as really strong, robust weather forecasting can make a big difference on how well you cope with a typhoon or a hurricane.
And yet, in the case of Sandy, even with that strong infrastructure and even with the knowing that it was coming a week in advance, it still caused a fair amount of damage.
Billions of dollars in damage, people died. So I think that's one of the things about climate change is it affects everybody everywhere. It's really one of those situations where we're all at risk from climate change, and there's a really common interest, therefore, in addressing it because everyone's, climate change doesn't discriminate, it happens everywhere.
So here are a few tips for journalists if the subject is the impacts of climate change. The first one is, be careful how you attribute causation. It is simply not accurate to say, for example, climate change caused Hurricane Sandy in the United States in 2012 or Typhoon Haiyan in the Philippines in 2013. What you can say, however, is that these highly destructive superstorms are consistent with what climate scientists have predicted would be the impacts of global warming. Second tip, illustrate the impacts you're talking about. If you're reporting, for example, on the impact of global warming in the Arctic region or in the Sahel Desert, find examples. An Inuit community, for example, whose village is slipping into the ocean, or where people can no longer hunt because they're afraid to go out on ice floes, or a Sahel farmer that is fleeing the expansion of the Sahara Desert. Here's the third tip. Find a good balance between scientific accuracy and readability. You always want to be correct in what you're saying, but there are ways and there are ways to put it. You could, for example, say sea levels are predicted to rise 28 to 61 centimeters by 2100 under the IPCC's most stringent emissions reduction scenario, and by 52 to 98 centimeters under a business as usual scenario. And that would be perfectly accurate. On the other hand, a much easier way to make that point would probably be to say, if humanity continues to emit greenhouse gases at the current rate, sea levels are set to rise up to a meter by century's end. Finally, when you're talking about impacts, make sure that you establish the context. What are your assumptions here? Are you assuming business as usual conditions, that is to say, no efforts at reducing greenhouse gases? Or are you assuming that humanity has made a certain level of effort in order to do that? You need to be clear in linking impacts to the specific scenario. So here are a few points to retain about the impacts of climate change. Number one, the severity of future impacts will depend almost entirely on how quickly we stop spewing greenhouse gases into the atmosphere. Number two, the best guess of most scientists is that if humanity can cap the rise in temperatures at 2 degrees above the pre-industrial benchmark, humanity should be able to avoid major climate catastrophe. Number three, climate change impacts interact and are deeply intertwined, much like the different strands of the Earth system itself. This means that relatively small changes can lead to dramatic outcomes. In nature, sometimes 1 + 1 = 3. And finally, number four, the biggest multiplier of human misery caused by climate change is poverty.